In recent decades, the livestock industry worldwide has undergone a profound transformation driven by rapid advances in science and technology. Once heavily dependent on experience and manual labor, animal husbandry is gradually becoming a modern, data-driven industry managed through automation and intelligent systems. This shift not only responds to the growing global demand for food, but also aims to achieve greater sustainability, efficiency, and environmental friendliness. On modern farms, machinery and technology play a central role in nearly every stage of production. Automated feeding systems, robotic milking machines, livestock health monitoring devices, and sensors that control barn temperature and humidity have become increasingly common. As a result, farmers can significantly reduce manual labor, minimize human error, and improve both productivity and product quality. More importantly, these technologies also enhance animal welfare, ensuring that livestock are better cared for and raised in suitable environments. One of the most notable and important technological applications in modern livestock farming is the automated feed mixing and distribution system. Large-capacity mixers are designed to combine various ingredients such as hay, concentrated feed, grains, minerals, and nutritional additives. These components are blended in precise proportions tailored to each type of animal and each stage of growth, ensuring a balanced and scientifically formulated diet. Such systems are typically integrated with weight sensors and centralized control software, allowing for accurate measurement of each ingredient before and during the mixing process. The collected data can be stored, analyzed, and adjusted flexibly according to the actual needs of the herd. Thanks to this approach, feed utilization becomes more efficient, waste is minimized, and consistent, uniform nutritional quality is maintained. Overall, the integration of automation technology with livestock farming not only delivers economic benefits to producers, but also contributes to the development of a modern, sustainable, and more responsible agricultural sector for the future. In modern cattle farming, advances in science and technology have transformed nearly the entire production process, especially in milking, a critical stage that directly determines both productivity and product quality. In the past, milking relied heavily on manual labor, requiring significant time and manpower while posing hygiene risks. Today, automated milking systems have emerged as an optimal solution and are widely adopted on large-scale farms around the world. When a cow enters the milking station, the automated system identifies the individual animal through an electronic tag or body-mounted chip. This allows key information, such as age, body weight, milk production history, reproductive cycle, and health status, to be accessed instantly. All data is stored and analyzed by centralized management software, enabling farmers to monitor the herd accurately and scientifically. Once identification is complete, a robotic arm begins preparing the cow for milking. First, the system automatically cleans the udder using water and specialized solutions to ensure proper hygiene and minimize the risk of infection. The udder is then gently stimulated to encourage natural milk flow. The milking cups are attached with high precision, ensuring an efficient process while keeping the cow safe and comfortable. Throughout the milking process, sensors continuously monitor milk flow, temperature, and quality. If any abnormalities are detected, such as bacterial contamination, foreign particles, or substandard indicators, the system automatically diverts that milk away from the main supply. This ensures that only high-quality milk enters the production chain, enhancing product reliability and market value. Milk that meets quality standards is immediately transferred into an on-farm automated cooling and storage system. This closed-loop process preserves freshness, minimizes exposure to external environments, and ensures food safety while extending shelf life. In addition to automated milking, precision feeding technology also plays a vital role in modern cattle farming. Based on data such as milk yield, physical condition, and nutritional requirements, the system automatically adjusts each cow's feed ration. Every animal receives the exact amount of feed it needs, improving nutrient efficiency, boosting milk production, and reducing feed waste. As a result, farming costs are optimized while herd health and productivity are maintained. Overall, the application of automation technology in dairy farming not only increases production efficiency, but also contributes to the development of a modern, sustainable agricultural system that is more animal-friendly and environmentally responsible. In the past, livestock manure management was considered one of the major challenges for medium and large-scale farms. The volume of waste generated each day was enormous, while manual collection methods were not only time-consuming and labor-intensive, but also caused strong odors, negatively affecting the surrounding environment as well as the health of both humans and animals. If not handled promptly and properly, livestock manure could become a serious source of pollution for soil, water, and air. However, with the introduction of automated manure collection systems, this issue has been addressed in a far more efficient and scientific manner. Modern systems are designed to operate continuously inside barns, collecting waste with minimal direct human involvement. As a result, the farming environment remains clean, dry, and hygienic at all times. Automated manure collection systems typically use a combination of conveyor belts, piping networks, and smart sensors. Depending on the barn layout, the equipment can automatically move along walkways, scraping, suctioning, or pushing manure into a central transport system. Sensors enable the system to detect location and waste volume, adjusting operations for maximum efficiency while minimizing energy consumption and reducing equipment wear. Once collected, the manure is transported directly to a centralized treatment area. There, the waste is processed using biological methods or advanced composting technologies to convert it into high-quality organic fertilizer. This fertilizer is rich in nutrients, safe for crops, and helps improve soil health while also reducing reliance on chemical fertilizers in agriculture.
These machines process cow dung into biofertilizer and various other types of fertilizer.
In Australia and several other countries with highly developed livestock industries, virtual fencing technology is gradually emerging as a breakthrough solution, bringing significant improvements to the management of grazing animals. Instead of building traditional physical fences, which are costly, time-consuming to install and expensive to maintain, farmers can now control their herds through advanced technological devices. Virtual fencing systems operate using smart collars fitted to livestock, each equipped with GPS sensors, a processor, and signal-emitting components. Farmers define virtual grazing boundaries on a digital map through management software. Although these boundaries do not exist physically, the system records them accurately and continuously tracks the position of each animal. When an animal approaches a predefined boundary, the collar emits an audible warning signal. This sound helps livestock gradually develop an awareness of grazing limits. If the animal continues to move beyond the boundary, the device delivers a mild electric stimulus, well within safe limits, to guide it back into the permitted area. Over time, the animals adapt to this mechanism and naturally comply with the boundaries without the need for direct human intervention. One of the greatest advantages of virtual fencing technology is its high level of flexibility. Farmers can easily adjust grazing areas based on seasons, weather conditions, or pasture quality with just a few actions on a computer or smartphone. This allows for more efficient use of natural feed resources, ensuring that livestock are always grazed in areas with the best grass quality. Unmanned aerial vehicles, commonly known as drones, are increasingly becoming an indispensable tool in modern livestock management, especially on farms with large areas and complex terrain. Thanks to their ability to fly flexibly at higher altitudes, drones allow farmers to observe and monitor entire grazing areas in a short amount of time, replacing manual inspections that are often time-consuming and labor-intensive. Modern drones are typically equipped with high-resolution cameras and advanced thermal sensors. This enables farmers to easily detect animals that have strayed from the herd, are injured, or show abnormal health conditions. Thermal sensors help identify changes in body temperature, supporting the early detection of illness before it spreads throughout the herd. In many cases, drones can also fly at lower altitudes and emit sound or visual signals to guide livestock in a desired direction. This is particularly useful in vast grazing areas where herding animals manually can be difficult. With drone assistance, farmers can quickly gather the herd, adjust movement paths, or guide animals back to safe areas, without the need to physically approach each individual. Beyond herd management, drones are also widely used to monitor pastures and forage crops. Aerial imagery allows farmers to assess grass growth, detect early signs of drought, flooding, or nutrient deficiencies. This makes irrigation, fertilization, and land management more precise and efficient. Overall, the application of drones in livestock farming not only improves management efficiency and reduces labor and operating costs, but also contributes to the development of smart, modern, and sustainable farming models. It clearly demonstrates the growing role of technology in transforming and advancing agriculture in the future. In sheep farming, wool shearing and parasite control play a critically important role, not only directly affecting animal health, but also determining the quality and economic value of the wool. In the past, these tasks were largely carried out manually, requiring skilled labor, significant time, and posing risks of stress or injury to sheep if performed improperly. Today, with the support of modern technology, automated shearing machines have significantly transformed this process. These systems are designed to optimize speed, precision, and safety, allowing wool shearing to be carried out more quickly and uniformly, while minimizing stress on the animals compared to traditional methods. During operation, sheep are guided onto a specialized conveyor system and secured in an appropriate position. This stabilization limits sudden movement, reduces stress, and ensures accurate machine performance. The automated shearing system then cuts the wool along a pre-programmed path, systematically and efficiently covering the entire body of the sheep. Integrated sensors that detect wool thickness and position allow the machine to adjust cutting pressure and shearing speed in real time. As a result, the wool is clipped evenly and closely without scratching or damaging the skin. This not only protects the sheep, but also produces a uniform, high-quality fleece that is easier to sort and process later. Once the shearing process is complete, the sheep move through an automated spraying chamber for parasite control. This enclosed chamber is equipped with strategically positioned nozzles that cover the entire body, including hard-to-reach areas such as the belly, legs, and neck. Protective treatments are applied in precise doses to prevent and eliminate external parasites such as ticks, fleas, and mites, while reducing the risk of skin diseases. The entire shearing and spraying process is highly automated, enabling the system to handle hundreds of sheep per hour while maintaining consistent quality and safety. This allows farmers to significantly reduce labor costs, shorten processing time, and improve overall herd management efficiency. Overall, the application of automated shearing machines and parasite control systems delivers not only economic benefits, but also meaningful improvements in animal welfare. It represents an important step in the modernization of the sheep farming industry, moving toward a more efficient, sustainable, and animal-friendly production model. In poultry farming, especially large-scale chicken production, ensuring that the entire flock receives adequate uniform nutrition at the right time is always a significant challenge. If feeding is not managed properly, chickens may grow unevenly, with some receiving excess nutrients while others suffer deficiencies. This directly affects animal health, productivity, and the farm's overall economic efficiency. For this reason, the introduction of automated feeding systems has provided an effective and sustainable solution for modern poultry farming. Automated feeding systems are designed to distribute feed evenly throughout the entire poultry house. Equipped with smart sensors and precise delivery mechanisms, these systems ensure that feed reaches all areas, giving every chicken equal access to nutrition. This is especially important in high-density housing, where manual feeding often leads to unequal feed distribution across different zones. One of the key advantages of automated feeding systems is their ability to control and minimize feed waste. Feed is supplied according to the actual needs of the flock, reducing spillage and excess accumulation in feeders. As a result, feed costs, one of the largest expenses in poultry production, are significantly reduced, while the housing environment remains cleaner and drier. In addition, these systems are integrated with portion control units and programmable timers, allowing farmers to set precise feeding schedules for each stage of the chicken's growth. Delivering the right amount of feed at the right time helps prevent both overfeeding and nutrient deficiencies. Consequently, the flock develops more uniformly, remains healthier, and experiences fewer digestive or metabolic disorders. Beyond nutritional benefits, automated feeding systems also greatly reduce labor requirements and management pressure. Instead of manually feeding birds multiple times a day, operators only need to monitor and adjust the system when necessary. This is particularly well suited to large-scale farms, where accurate and continuous management is essential. Numerous studies and real-world production results show that farms using automated feeding systems tend to achieve more stable growth rates, lower mortality, and higher economic efficiency compared to traditional methods. By improving flock health and productivity, this technology also enhances profitability and supports the long-term sustainability of modern poultry farming.